This video will show you how to run Factorial ANOVA in SPSS. Here is the data. So we have the ice cream rating, which is a dependent variable. And we have two between group independent variables, age group and gender. These are the coding. So if I go here, click on the value label, and you can see the codes again. And so for age group, I have 3 groups, and for gender, there are 2 groups. So this is also Factorial ANOVA is also called 3x2 ANOVA. So to run the analysis, we go to Analyze, and then on the so they go to General Linear Model, and then Univariate, and then we'll go to the rating. Put the rating in the dependent variable, and then age group and gender. These are the fixed factors. Factors are also called independent variables in ANOVA. So we're going to click on options, and we're going to check the descriptive statistics, estimates of effect size, and homogeneity tests. Because it's a between group ANOVA. Yeah, so that's why we're looking at homogeneity tests. And then we're going to continue. And then we're going to also check plots. And so for the plots, I'm going to look at, I'm going to put each group in a horizontal axis and add. I'm also going to look at to have a chart for gender. Yeah, so put it gender in horizontal axis and add. And then the other graph I'm going to look at is I'm put age group here, and then put gender as separate lines, and then add. So I can change this. So I'm going to look at a bar chart, continue, and then OK. So then in the output, so you can see that these are the descriptive statistics that we did. And you can see for the table, and so we'll have this a total mean for girls and total mean for boys, and you can see that girls have a higher rating than the boys on average. If we're looking at the age groups, we're looking at the total mean for each group, and we can see that the younger kids tend to rate the ice cream higher than the older kids. Within each group, we can also see how girls and boys rated the ice cream flavor. And if you look at this, you can see that the girls tend to rate the flavor higher than boys, no matter which group we're looking at. And we can also look at the charts. And so the charts that's based on the table we read. Yeah, so these are the average rating by each age group, and that is when we can see that as children get older, the rating is lower. And this is a chart for boys and girls, their average rating. Girls tend to rate the flavor higher than boys, and this put both dependent variables together. So we can look at how boys and girls rate the flavor within each group. We can see the trend kind of same. Girls tend to rate higher than boys. We can also look at the age group by the gender. So for girls and also for boys, they are the same. Younger kids tend to rate the flavor higher than the older kids. So now let's look at the tests. Yeah, so first we'll look at the Levin's test for equal variance. And so this is a test for the assumption, and because this is a between group ANOVA, one of the assumptions is the groups have the same variance. And so this is a test of that assumption, because the p-value here is larger than 5%. So the assumption met, because now the testing is the variances in the population equal. Then we look at the ANOVA table. This is the ANOVA summary table, which has a lot of more information than we need. So I'm going to switch to this table here, which is have the same thing, but I kind of highlighted those are important ones, and those are usually that you will report out. Those are the highlighted. And these are the effects for each of the independent variable, which we call the main effects, and also there's interaction effects, and error variance and total variance here. Yeah. So look at the main effect of H group. So we look at the H group row. And so if you look at scroll over here, so you can see that you look at the SIG column. Yeah, so H group, the p-value is smaller, less than 5%. And that means that there's a significant H group effect. And just like as we observe the table, yeah, we do see there's a difference in age groups in their ratings. And this is partial eta squared as reported in SPSS. That's the effect size. So it tells the age group effect after partitioning out the other factors. And then, so if we look at the gender effect, we will go to the SIG column here. Yeah, so you can see that for gender effect, the p-value is larger than 5%. So there's no significant difference in ratings between gender. And as we see that in the descriptive statistics table, we do see that girls tend to rate the flavor higher than the boys, but it's just not large. The difference not large enough to be significant. And then this is the interaction effect. And so, and if we look at the column, the SIG column here, and so it tells us that there's no significant interaction effect. So that means that the effect of gender is consistent across the different age groups, or vice versa, the effect of age group effect is also consistent for between each level of the gender, and which is consistent with what we observed in the chart here. So within each age group, the gender effect is the same. And if we're looking at for girls and boys, the age group effect is also consistent. And then, so if I go back to the table here, yeah, so what we have here is just so since there's no significant interaction effect, and we don't have the main effect. And for the main effect, yeah, if any group has more than two groups, yeah, so once we have a significant main effect, then we need to some follow-up test to find out between which group the difference lies. So here, yeah, we do see that there's a significant age group effect because we have more than two groups. We need some post hoc analysis. So we need to follow up the test, significant main effect. And what we're going to do is we're going to rerun this analysis at the Factorial ANOVA. So now we need to look at, yeah, we click on this estimated marginal means. Yeah, so we're going to put age group here, and then going to check compare main effects. So we're going to use this Bonferroni procedure for the comparison. Yeah, so, and then continue, and then that's okay. Yeah, so some of the tables will be same. Yeah, but the one new table is what we're looking at here. Is the pairwise comparisons between the age groups. So like here, yeah, so there's a 5-year-old compared with 8-year-old and compared with 12-year-olds. So you can see that when we compare 5-year-old with 8-year-old, this is the mean difference, and it does not reach significance. When we look at 5-year-old with 12-year-old, the difference is rating difference, 2-point difference, which is significant. And you see that it was flagged by the asterisk, and also p-value is small here. So there's a significant difference between 5-year-old and 12-year-old. There's another significant difference, which is between 80-year-old and 12-year-old. So what do we see here? Yeah, so for this Factorial ANOVA analysis, yeah, so we do see there's a main effect of age group effect. And yeah, so the difference in the age groups is mainly due to the 5-year-old and 12-year-old, and also the 80-year-old and 12-year-old. Okay, so that is for the Factorial ANOVA analysis. Thank you for watching.